The second part of 5.2, we dealt with the exponential or rational expressions. Now we're going to hit the radicals. Okay, and here's what I'll tell you about the radicals. I'll have some students that, and I am completely okay with, that they will turn any sort of radical into a rational exponent, and I have no issue in that. Okay, because to be perfectly honest with you, it's easier for students to see. Okay, for whatever, because you've dealt with exponents and you know the properties there, or I feel like a lot of students know those properties better. So I will have students, and I'm going to show you both ways, like on A and B. Okay, more A than B probably, that you can do it two different ways and do it whichever way is easier for you. Now, with that, I will tell you, if it starts out as a radical, you need to finish your answer as a radical. Does that make sense? So however it starts is how it needs to finish, unless you have just a straight 2 or a 3 like you have in the example there. Okay, so with any of these, if you have the cube root of 12 and the cube root of 18, okay, it's a product. Same way B is a quotient. Basically, all that means is you can separate everything out and you can go from there. Now, I'm going to show you the first way, and then I'm going to show you the second way. The first way is just the original way of doing these. Okay? The original way of combining them, if they are underneath the same radical, then you can multiply those together. So if I have the cube root, I can take 12 and I can take 18 and I can multiply those two together. Well, 12 and 18 is 216. Okay, and I'll have the cube root of 216. Now, from here, I have the cube root, so I need to look at my list. Is 216 in my list with the cubes? Yeah. So what's the cube root of 216 then? 6, right? Is there one answer or two answers? One, because it's odd, right? Okay. So this one's pretty straightforward and should be pretty simple, right? Okay. Now, the thing is, if you want to combine them, no issue in that. Okay. If you, like in this case, you really can't separate the 12 out or separate out the 18. So I would say putting them together is a good option here. Okay, I will have some students, to be perfectly honest with you, that'll do something like this, and if you do it this way, that's completely all right. Kind of just taking what we had and rewriting 12 to the 1/3 power and multiplying it with 18 that is also to the 1/3 power. If you don't want to do it this way, you don't have to. I'm just showing you what in the past, I've taught this a long time, what students feel more comfortable with. They're going to do the same thing. They're going to take the 12 and they're going to take the 18 and they're going to get 216 and they're going to have it all to the 1/3 power. They're still going to look at the list. They're going to see, hey, I've got a 216, and they're still going to write down that it's 6. Okay, it's just another option. Okay, all it is another option. Same way on B. Whenever I have anything like this, if they're both underneath the same radical with the same root, I can rewrite this as the 4th root. What is 80 divided by 5? 16. Again, look down my 4th list. Do I have 16 or a number that's divisible by 16? Yeah. What is the fourth root of 16? Plus or minus 2. I'll have some students, to be perfectly honest with you, that you can simplify the 80. Okay, and I'll kind of give, the other route would be to do something like this and have on the top, I'd have the fourth root is 80 divisible, basically going through my list. Can I divide, 80's right here, can I divide 80 by 16? Yeah, what is it? 5, right? And they'll do this over the fourth root of 5. Well, what's going to happen to the fourth root of 5 and the fourth root of 5? They're going to cancel. What's the fourth root of 16? Still 2. Okay? There's no... Which way's right? Both of them. Okay? If you want to simplify the radical just like we would before with it being a square root, you can do that. That's okay. Alright? It's completely up to you. It doesn't make me any difference as far as how you want to do it. Okay? It's completely up to you. Whichever way is easier, do that. If you see that, hey, I can divide 80 and 5, since they're both underneath the same radical, I can do that. Now, a couple things to keep in mind. An expression involving a radical with an index in, okay, basically if it's like an index of 3, 4, 5, 6, so on and so forth, okay, the number underneath, just like it was with a square root, like if I had... the square root of 50. Okay, before, if you had a number that was just the square root of 50, could I leave it like that? No, what would I have to do? I'd have to go down my list, and then what would I do? I'd climb it, right? Okay, climb it until I get to the 25, and I would break it up as square root of 25 and the square root of 2. Square root of 25 is plus or minus 5, square root of 2. Nothing's changing here. It's the same idea, but now I'm just using different lists. So instead of just staying in the squared list, I'm going to go to the cubed list, or I'm going to go to the fourth list, or the fifth list. If there is a perfect cube, or a perfect fourth, or a perfect fifth, then I need to take that out. So like if I have the cube root of 135, again, just like we did here earlier, I'm going to go here. Can I divide it by 125? No. Can I divide it by 64 evenly? Can I divide it by 27 evenly? Yes, no, maybe. Yeah? Okay. So I can break this up into the cube root of 27 and the cube root of 5. Well, what is the cube root of 27? 3. So I'm just going to have 3 times the cube root of 5. There's only one answer, okay, because it's cubed. Nothing's changing. We're still doing everything the same way. Now, in this case where I have the on B, okay, the other one says no radical can contain a fraction and then no radicals appear in the denominator. Okay, so I have a radical in the denominator here with B. What I would suggest to you is if any point in your denominator especially, okay, do I want to write, do I know what 8 to the 5th is? If I write out 5 8s. 1, 2, 3, 4. Boom, we got lucky and we still had. That's 3,768, right? Do you see 8 anywhere else in this list? Where? Cubed, right? Okay. It's almost like a word search, and I'm looking for a number instead. So I have an 8 on the bottom side. I'm looking for an 8 anywhere I can go. So if I have an 8 right here, how many 2's do I actually have in the denominator spot? 3. So what can I multiply 8 by to give me a number to where I have 5 2's instead of 3? Or better yet, I've got to have a perfect fifth root on the bottom side. What times 8 will give me a number in this list? 4. Does everybody see what I'm trying to do? Okay. 8 times 4 gives me 32. Well, what's the fifth root of 32? 2. 32 is a lot better number to deal with than 3,768. Do you agree? Yeah. Okay? I don't want to deal with a number that big. Okay? The top side still does everything like we did with a square, so I'm going to have the fifth root of 4. What's 7 and 4? 28. So I'm going to have the fifth root of 28 over 2. All I'm doing is using my list to my advantage. I had an 8 in the denominator spot. I need to get a number in this list to either make it 1, 32, 243, 1,024, 3,125, so on and so forth. Okay? The smaller the better. Okay, the smaller the better. I'd rather deal with 32 than 3,000 or 32,768. Same way here in the middle where I can't have a radical in the denominator, so if I had an imaginary number down there, or really we've done these before, what do I need to multiply? If I have 1 over 5 plus the cube root, or excuse me, the square root of 3. What do I need to multiply the top and the bottom by? Nope, more than that. 5 minus the square root of 3. Okay? Remember, we always go with the conjugate, okay, of my value. So if it's a plus, I've got to go with a minus so then I can get rid of everything. For time's sake, I'm going to move on and go down to simplifying the expression. Now, whenever I simplify, do I know what it says simplify, do I know what the fourth root of 10 is? Huh? What? Huh?
10,000.
No, that's 10 to the fourth. We're talking about the fourth root of 10. It's somewhere in here, right? So that's going to be some random decimal. Don't give these too much respect. What if I had 1x plus 7x? 8x. You know what the fourth root of 10 plus 7 times the fourth root of 10 is? 8 times the fourth root of 10. Don't give it too much respect. Okay? It's really just another variable. Same way on B, I have 8 to the 1/5. I don't know what 8 to the 1/5 power is, nor do I really care. Sorry, but I really don't. If it was 2y plus 10y, what would my answer be? 12y. So what's going to be If I have 2 of these and 10 of those, what do I have? 12 times 8 to the 1/5 power. Now, C's a little bit different because I have the cube root of 54 and then I have the cube root of 2, and they're subtracting. This should give you a hint as far as what I have to do. I can't do anything with this. So where do you think I probably need to look? Probably the cube root of 54. So again, go down my list. 54 is right here. Can I divide 54 by 27?
Yes.
Yeah. What is it? Cube root of 27 times, I bet it's 2. How do I know it's 2? Well, common sense tells me that it's probably going to match right there. Now, what is the cube root of 27? 3. So I'm looking at 3 times the cube root of 2 minus 1 times the cube root of 2. Just kind of added the 1 in there. So what's my final answer? 2 times the cube root of 2. Whatever number you can get to match inside the radical, that's what you're ultimately looking to do. You can add x's, you can add variables, you can add those together all day. It's all it really is. Okay? We're simplifying. We're not trying to solve anything here. Not yet. You try. Last one is I'm going to go to A here with the cube root of 64 and the y to the 6th. Always look at each thing individually. If I have the cube root, cube root of 64, and I have the cube root of y to the 6th. Is 64 in my perfect cube list? Yeah, so what's the cube root of 64? 4. So this is just going to become a 4 times. Now, if I have 6 y's, how many groups of 3 do I have? Y squared. Because if I have the cube root of y to the 6th, that's the same thing as having like the cube root of y to the 3rd times the cube root of y to the 3rd. What's going to happen here? Y. What's going to happen here? Y. What's y times y? Y squared. All I'm really doing, yeah, like that's my answer. All I'm really doing is taking 6, dividing it by 3, and getting the 2. Don't overcomplicate it. You've already done these before with the squares. Now you're just expanding your list is all you're doing. Okay, you did it all day with the squares. Now we're just going to go to the thirds, the fourths, the fifths, so on, so